How's it going, everybody? We'll just kind of go from where we were yesterday, or not yesterday, Thursday, I guess. So last time we were looking at this we were going to implement this here, which is generating reaching conditions for a particular basic block, which means figuring out all of the logic statements required to be true in order to get to this point. And we were going to do some really hey JT, we were going to do some kind of hacky things that I don't really think anyone necessarily approves of, but I thought that it might be a fun way of doing it. I have a feeling that I'm going to end up doing it differently in the future, particularly when simplifying things, but it'll at least be like a fun little exercise. So let's go ahead and just try this. So the region header is going to be the basic block that starts this sequence of an acyclic region. And the basic block that we're passing in, we're going to create a, I guess it'd be easier to just look at the these calculating reaching zone conditions. Like if we look at this, I think it's reaching conditions. Come on. Oh, I need to run everything probably, maybe. Yeah. We'll restart and run all of these, and then we should get what we want. Oops. What happened here? Did I change that? Oh no, I guess I changed it to just regions. Let's see. Nope. Oh, right. We need to do an AST dot medium level IL AST. Nope. Even worse, I messed up a bunch of stuff and then never checked it. Oh, right. I have updated and they still haven't accepted that PR because I haven't made some changes to it yet. So let's go and fix that real quick. I think we've got, no, this is not the one I want. I want this one. And we'll just go ahead and add it back right here. All right, and we should just be able to restart and run all. All right, closer. What did I forget to return something from regions? I did. Are you kidding me? Man, I am failing all over the place now. Expected an indented block? Yeah. I use Jupyter sometimes. I use it in my training classes. Actually, I think it works really well for particularly teaching people doing API stuff. I like using Jupyter for binary ninja stuff. Now, what have I done here? Is there something up here that got expected an indented block? Okay. Oh, wait. Oh, I'm looking at the wrong place. Oh my gosh. Yeah, it's just Jupyter running on the headless API right now. I would like to do some stuff where I actually do some fun stuff with the UI, tying them in together with a script writer. But that's down the road a little bit. I've got some other projects I would rather deal with first. All right. Yep. Just having this happen a bunch, huh? Changed all those properties and then calculate reaching conditions. All right. Whoop. Did I not move that one in? Oh, reaching conditions. I changed that one as well. Yeah, there we go. Okay, so anyways, to what I was going to get to was the reaching conditions are these paths that they have to take to get from one particular thing. So like in this case, the basic block of 0 through 6 to get to hex 60 through hex 69 requires us to take the true branch that takes us to 6, the false branch that takes us to 11, and the false branch that takes us to 60. So if we want to then take those and turn them into the logic statement, so like in this sequence for this region that we're in, we're going to generate an acyclic region, or structure it. The first thing we did was we sorted it based on whether or not something was dominated. So that's, let's see, I had that here somewhere. Yeah, this one. Oops. What do we have here? Oh, yeah, I guess I need to do a self. So let's do, I don't want to do that here. Let's just get rid of this cell because it doesn't really make any sense. So I want to start an acyclic region. We have a region header and then a.regions. And I think that's a dictionary, right? Yeah. Oh, gotta restart because I changed that one thing. Not implemented error. Okay, cool. So where were we? So we were right here. So this is where we're going to implement the actual medium level IL for that. So in here, let's say I'm gonna just comment that part out. Self dot reaching conditions of the region header and basic block. Oh, key error. Oh, right. If the BB is the region header, let's just continue because we're not gonna do an if statement for that. We already have established we're already there. All right, so we have our structure acyclic region. So these are the if statements for each of these. So we then structure it as if not whatever this condition is, then do whatever's in that basic block. If not this and not this, then do what's in that basic block. And then if true here, do what's in that basic block. And so we can signing from a, yeah, we'll get that in a second. So what we want to do then is let's actually get the, well, you're in luck, Anorexic Seal. Hopefully you'll learn how to use Binary Ninja from some of this. And also you might learn some bad habits as well. Hopefully my sipping coffee is not too loud and disgusting. Sorry. All right, so where were we? I think for edge in self.reaching conditions. Let's do first, to make sure we've got everything, edge.type and then edge.target. Let's do self.function edge.target. Let's see if that it's not blinding white. It's called quiet light. And it's not white. The background's like cream colored or something. I don't even know where I found it. There was actually one recently that I wanted to switch to, that's got this like nice pink background. It looked really soothing and I really liked it, but I cannot find it anymore. Wow, you came with your bustin' chops material today, huh, Marcus? All right, so what am I missing here? Invalid syntax. There's a parenthesis. Yeah, okay, that should fix that. All right, so I can probably switch to just a single block for now. Oh, list has no attribute type. Oh, it's multiple lists. For condition in self.reaching conditions. And then this is for edge in condition. All right. Maybe we'll clear some of our cells after this. Oh. Really? You'll find that most of the time, if you're new to the show today, hello, you'll find that most of the time fucking around with Binary Ninja mostly means messing up and writing typos in the Binary Ninja API. All right, can't sort like that. Get item. Oh, it's a basic block. That's right. I actually want source. All right, let's clear some of these out. We'll change this first. All right, we don't need you. I don't think I need that one either. Oh, I can't select them like that. No, I need main. We'll get rid of those first. All right, we can move this up here. And get rid of those, and then we can get rid of that there. It's a little bit nicer. Oh, the source doesn't have one as well. Oh, that's right. So we can actually just do like that. I don't actually need self.function. Oh yes, I'm also very good at finding binary ninja bugs. Nope. Now what am I doing wrong? Source should be a basic block. Huh. All right, let's see what edge.source is just by itself. Oh, is it not reloading my, maybe that's the problem. It's not actually reloading it. Oh my gosh. There we go. Branch type dot false. Okay, it is a basic block. So then, oh, that's interesting. What's the none? None of them are empty, it looks like. Oh, it's probably the return value of the thing. All right, so I should be able to do this now. No, gotta restart it. So we're actually not gonna, there we go. There's the statements I want. And I want the dot condition if edge dot type equals branch type. Oh wait, no, it's a different thing. It's a branch dependence type. Or maybe it's dependence. Really? You're not gonna give me any suggestions? Oh, okay, fine. I'll go look it up in the API. It's an enum. And it is called IL branch dependence. That's why I couldn't find it. It starts with IL. Because there should be some. Oh wait, no, I'm looking at the actual edges, aren't I? So it's the unconditional branch. So maybe I want branch type. Let's try it and see what happens. So we've done some pseudo C or whatever before, but I didn't like how it was going. So now I'm implementing a white paper on a decompiler. And we should be pretty close in a second. I'm going to mute for a second. Sorry about that. I have this giant cookie that I've been forgetting to eat. And so I wanted to take a couple of bites of it. But I didn't want y'all to turn this into an ASMR video of me eating cookie. A giant chocolate chip cookie from Starbucks. I'm actually pissed because I did a mobile order and ordered a confetti cookie, which are these awesome like sugar cookies that have like this hint of citrus to them, and also half of it is like dipped in icing. So, and they're amazing. And instead I get home and I open it and it's a fucking chocolate chip cookie. So fuck them. All right, so I don't want to output if it's an unconditional branch, because then it's just a jump. And I don't care about those. I only want to see the condition if it's a condition. Yep. Oh, right. All right. So the next thing that I want to do is actually do this. Oop. I'm sitting here looking at OBS and trying to move my mouse over, but I'm already at the left side and it wasn't moving. Oh, glad that you're gonna hang around for a little while, Stormcourt. You usually peace out pretty early. Glad to hear you have some tea. All right, so I wanted to do that. Okay, so there we go. We have one that actually has something. And actually, I want to do this like, I'm going to do it like this. This is actually going to be pretty get rid of that. And then move this back a little bit. Is there a link to the white paper? Yes. And you know what? I should do that more often. I linked it last time, but did not link it this time. It is the seminal paper on writing a decent decompiler called No More Go-Tos. So let's see. So we've got those two there. We don't need the branch part printed anymore. So we've just got the condition. Let's do it like this. We'll just put true there if it's an unconditional branch, just to make it simple. Go ahead and change that, do that. I got to do it like this. Actually, maybe I can put it just right here. Seems like it likes that. No, it does not like that. Oh, no, it's something else. 196. Oh, no, it's definitely that. It did not like that. It's a parentheses. F string. Yeah, it's right there. What did I mess up? Oh. All right, let's just do this like this. It's pleasantly short, but it also is a bit ambiguous at times. Now, I will admit that I've only read like parts of it. Really? You're not going to give me any? I think it's just false branch. Yeah. And take the reaching conditions out, I think. Okay, well, non-type is not scriptable. What did I mess up? I guess we'll just do this first. Why would that become none? Let me do that and see if that generates them. Actually, why am I even doing this? I should just do this. There we go. Maybe that'll fix it. There we go. And we can don't need to print this because it just prints them. We're currently printing everything ourselves. There we go. So let's print the BB. Whoa, I got on caps somehow. Oh no, just do there. Actually, let's see what that looks like. Cool. Let's try this. Why are you doing that? Okay. I do this because you can't slice a basic block. Oops. What did I mess up there? Oh, right. Oh, why do you have a little space there? That's weird. Oh, right. No, these are just little tiny changes, but just trying to make it look a little nice. That looks pretty cool. No, it's odd that it's got that ESP thing right there. Let's see, what are we looking at? Something happens to the stack. What is happening to the stack here? Does it think F open is something? It's just fixing the stack right there. Oh. Oh no, that makes sense. It's adding 8, then doing that, pushing those two on. Yes, this is the bomb lab, yes. It's what I'm using as my example for decompiling. It was just some random like crack me thing I had lying around. I wonder, I must think this is like, let's see, cdecl is the one that requires you to pull stuff off. So let's try putting that on the front. And then doing, what is it, int fd, and then, wait, no, fopen is the file one. I don't know if I have the file pointer thing. File, and, you know, let's actually just go ahead and check it real quick. I don't want to mess it up. path mode. Yeah. All right. Ah, that looks like it fixed it. Yeah, there we go. Okay. Go ahead and save. Oh, did I save the right thing? All right. That should fix it. Oh, we didn't actually print anything that time? That was weird. What happened? Where did my prints go? I guess we'll restart and run all. Okay, it still remembers that. I still have print statements. Let's see if it's not printing anything. Whoop. Accidentally hit Shift Enter in Visual Studio. It's nice that Visual Studio will like take things and run them if you hit Shift Enter, but sometimes when you mess up. Okay, it is not printing anything now. Did something happen to our ordered region? I swear I didn't change anything here. Oh, yeah. That's a little weird. What the fuck happened to you? Did the basic block numbers change or something? Oh, yep, they did, because I got rid of all the stacks-based stuff. So now my number is off. It's 2 instead of 6, I believe. Oh no, it's gonna be 3. Because the first basic block is not in any of the regions, as we found out. Whoops. There we go. Now we get stuff. Cool, that looks kind of nice, right? Let's I don't like the tab thing. 1, 2, 3, 4. 1, 2, 3, 4. And then, so that's all the conditions for, oops, for that particular one. Ugh, I hate when those little things in the Binary Ninja stick around, the QT things. So I don't have to print that out anymore now that it works. So it looks kind of messy at first, and they talk about this, like we haven't done any sort of transformations on the if statements or anything like that. But we get if not EAX not equal to and not EAX not equal 0. So if EAX equals 2 or EAX 3 equals 0, which is going to be this one down here. Now that's interesting. AX4, where are we? Okay, maybe we are backwards. These need to be, these are not in order. So that means that it is backwards, where? Right here. Maybe I did get them backwards last time and I didn't realize it. Let's see, that should flip everything. Yeah, so if EAX is not equal to 2, then we go down that other direction, this one. If EAX is not equal to 2 and if not EAX equal to 2 and not EAX not equal to 0, then we do this one. And then if not EAX not equal to 2, then this one. And I think that's okay. No, this one still needs to be before this one. So what is going on here? This needs to be, so that's where EAX3 is created. So what's wrong with that sorting? Actually, what I could probably say is lambda, just do a lambda I here. Let's see, because since I'm in an acyclic region, I should just be able to do I.start. And I think if the starts, ugh, man, Qt, you're killing me today. Can't get it to go away. There we go. All right. So because of the fact that it's an acyclic region, if it has a higher basic block starting number, it must be come after sequentially the other ones. Yeah, that looks better. So if EAX is not equal to 2, if EAX equals 2, if EAX equals 2, and EAX equals 0. So then what's the next part that we do? I think this is where we want to actually start simplifying things. Now, the nice thing about this one in particular is that it does separate this EAX. It knows that these are two different EAXs, because generally when something gets switched, like if it's not dependent on a previous EAX value, it'll create a new like index of that variable. So what we want to do now is simplify, I think. So I think it's time to bring in the big guns. And let me see. Do I have it already? I do. Cool. Let's see what all we need for this. We're gonna need bitback at least. what is it, bitvex sort. Y'all are gonna see how unfamiliar I am with Z3 and how much I forget of it every time. Gonna remember anything? Cool, okay. I want and, I want or, I want not. I'm gonna want solver, simplify. That should be good enough for now. And let's make a condition solver. No, let's just do it with Z3 functions. All right. Actually, I remember what I was going to do. I was going to do the medium level IL thing first. You want to do that, or do you want to do Z3? What do y'all think? Which would you like to see? Oh, come on. Somebody give me something. Z3? So I can see you sweat. All right. Let's go. What am I doing? Did you contribute 100 thingies? I don't even know what those things are. If you did, thank you. I appreciate the, like, $1 I think you gave me. All right, so let's do some Z3 shit. Def make variable. I have no idea how Twitch works either. I barely cobble this stream together every Tuesday and Thursday. Yeah. All right. Turn bitvex. I think it's like this, right? Yeah. Size. Wait, no, that's not what I want. I want bitvex. Bitvex name. This is going to be the variable name. And hopefully it has a name. BV, not binary view. That's going to be the number of bits. So that's going to be var.width. That's going to be interesting when we get to fields. Go ahead, add variable so I can get some type annotation going on here. I'm wondering if I can do this without SSA. If I may need to get the SSA, I'm kind of hoping that SSA has handled all of the things that I need to know about it already. No. Is it type? think it's source type, yeah. Actually, I think I can just set var.name. I don't think it's is it a property? No. Yeah, it's not a name or a property. That's cool. We'll just do this. Wait, does var have an architecture? It does have a function which has an architecture. So you would think doing get register by index would be var.index, but var.index is actually, I believe, that underscore number that you see on some variables. So it's slightly confusing. So like this EAX underscore 3, I think that is the index value. So if we look at dest here, oops. That's very confusing. Oh, it's a call, that's right. All right. Oh, no, index is something completely different. I think it's maybe like the variable, like the order that the variables are made or something. But you have the storage, and this is get reg by index, I believe. Nope. Get reg. Yeah, bb.arch. If reg in really? I'll say really out of frustration, not with Python, but with myself for being bad at it. Get reg name, I think it is what I want. And then we come up here and get this. And you get EAX. Now, if you do that on like 14.dest.storage, you would get this because this is a negative number. And negative numbers come out to be temporary variable names. So if you see something like this, this means that they forgot to check what type the dest is, or the variable is, before trying to output its name, reg name. So this one's a stacked variable source type, which means that minus 44 is minus 2c, and you see this is variable 2c. So that concludes our variable naming convention lesson. So generally, I think that's the only time that these variables don't have a name, is sometimes something will get messed up. But we'll do a not implemented if it happens. And that should give us what we want. So oh, I know what we should make. Let's make a condition visitor. All right, and I am gonna need BNIL visitor. Oh no, I want. No. I think that's right. All right, let's see. What do you not like? Oh, right. All right, and what are you mad about right now? Oh, yes. I need to change that over. We'll simplify those though. And this became a basic block node. All right. So here, we're going to make a condition visitor that comes from a BNIL visitor. I don't know if I need anything here. So we're going to need comparisons. Visit, we'll just do a first one. So left is going to be off.visit left. Right is going to be right. And then we're going to do a return of left equals right. I guess we'll have to do all of these. How many do I need? I need not equals. That's basically it for this one, which is fine with me. We'll start with that. Not equal. All right. Then we're gonna do visit mlil var. This is where we have to actually do stuff with Z3. Get rid of that. All right. Oops, that was the wrong place to put that. I don't even need you open. I want you in here. Condition visitor. All right. And I'm gonna need binary ninja. We'll import some stuff. Variable source type. We'll probably need more stuff later, but I'll deal with that when it's a problem for future Josh. So here we're gonna make a variable of expression.source. And then we'll just return that, I guess. And if we have a const, we will just return the constant, because we can do that with Z3. And then const pointer will be the same. All right. What else do we need? Let's look here. We need set var. No, maybe we don't. No, we're just still looking at conditions. I don't need to step through a bunch of stuff. So this might be enough just to do our condition. Yeah, so we can come down here, and for each of these conditions, oh, I know what I need. Let's do this. Let's do a self.result equals none. Wait, no. I think maybe we need a solver. Solver has simplify on it, right? Or no, simplify is just you pass in the solver. Oh, that's right. I need not. Oh, I think I do. I think I'm gonna have to actually do a combination of the Z3 and the medium level IL part. So you're in for a treat. Forgot about these. It's kind of funny. I don't even know what song I'm listening to right now, but it's got the chorus is something about you can simplify and reduce. So that's pretty funny, since that's actually what I'm working on, is simplifying some logic expressions. Let's see. It's Simple Romance by Coin is the name of it. Ugh. All right. So I'm actually just gonna, damn it, I keep hitting my caps. All right. Oops. I should just do like a visit both sides. That's nicer. I'd have to get the not equals part for that. Is there a not equal? I know there's like a UGT. Yeah. No, I guess not. Okay. I'll see if I can figure out a way to do that later. But I might be able to simplify these even farther. All right, got that. Let's keep this around, but I'll just comment it out for now. All right. Then super. Forgot where I was for a minute. And here. Oh, condition. Add. No, that's not going to work. All right. Actually, I'll just do simplify. And we'll do condition.add self.visit condition, and then we'll do simplify on self.condition. I think you can call simplify on a solver. Let's see. I think I can do multiple ands, right? We'll find out. Cool. No, okay. Maybe it's simplify? There's no way. All right, what is it called then? S dot. Set? No. Now I can't figure out how to get it. Yeah, I just did a duress. Thank you for the, where is that? Oh, I think I already deleted it. Yeah, the left thing is gone. Okay, now how do I get... What does help do? Oh, God. It doesn't help me at all. All right, to the Googles. D3 simplify solver. Oh, I don't want to look at the like actual D3 stuff. But you know what I can do is make this really easy. Ba-ba-ba. And actually, I don't need this. I can just go return, because all I need is the thing that comes back from it. All right, here's where I need to do the medium level IL part. Okay. All right, so what I want to do is all right, so all right, so self.function, this is medium level IL. No, I don't want to do append yet. I want to collect the expressions. Expressions.append. So I'm going to create a list of medium level IL expressions. And I want edge a single one is edge dot for edge in condition, because these are the reaching conditions. If edge dot type is branch type dot unconditional branch, then continue, because I don't give a shit. All right. Otherwise, append edge dot source -1 dot condition dot expression index. Let's do this. If edge dot type, this is where we're going to get dirty. Branch type dot true branch, then we're going to append it like that. Else, expressions dot append self dot function dot expression, and we're going to create a new medium level IL expression. And this is going to be an MLIL not, and A is going to equal, I don't need that, edge dot source -1 dot condition dot expression index, and size is going to equal, I need to clean this up. I think it's 0. I'm going to leave it at 0. I don't need to know the size of the thing. All right. So we've got that. Let's close this so I got some more space. And that's going to return an expression index and this is going to be then okay, let's do and expressions here and for expressions here. So then this is going to be or expressions, and then when we finish here, we're going to do and expressions append I need to reduce this, so can I do a reduce on this maybe? I think I need, get rid of that, reduce. Let's see if I can do a reduce with this. Where was I? Right here, okay. And expressions dot append reduce, and the function I want is going to be lambda ij equals and ij. No. It's going to be current, no, self.function dot expression medium level il operation dot mlil and then a is going to be I, and that one's going to be j. And then here, wait, yes, okay. And then here is going to be our for expressions. And then for expressions will become a list again. So what we're going to do, if you can't tell quite yet, is, oops. So for a, why is that? I think let's save. Okay, so for each condition in our reaching conditions, which is a list of edges that we have to take in order to get from the region header to the basic block, for each of those conditions, we'll take the edges, ignoring conditionals because they don't matter. For true branches, we'll collect the expression index of the condition, because an expression index is different than the instruction index. And then and if it's a false branch, we'll create a new expression that is a not of the original expression. Then we will keep all of those in a list, and then when we come here, we will reduce those. I'm not sure what happens with the default if you only have one here. Maybe it just doesn't do anything. It doesn't call this function if there's only one left. So then once we do that, we will reduce this by calling expression over and over again, anding those, ORing those together. And then once we finish that, put this down here now, make sure I'm in the right place. For condition, yes, and then come here, and now that we have the AND expressions, we can do the same thing where we reduce lambda ij self dot function dot expression, and with this one we'll do a medium level il operation dot mlil and those two. That there, get that there. And now we're returning the expression index of our combined conditions. I don't want to return that though. What I want to do is current, oh no, I keep typing that. Self.function dot, actually maybe I can just do a return medium level il instruction. That is going to be self.function And voila. Tab that in. And now we're returning an instruction object that is the expression of all of our ORed things from each of those edges ANDed with every condition. So if there's multiple conditions, fuck, I got that backwards again. It needs to be this way. The edges need to be ANDed together, and the conditions need to be ORed together. So this will be OR expressions. This will be OR expressions. Oh, throwing my mouse around and then locking my screen. I am super smooth today. All right, so OR that. And those. And those. And those. And then OR those. Okay. So now, let's see what happens. I didn't finish the cookie. I haven't been eating it. Thank you. I'm going to mute for a second and eat a couple bites. Even though it's the wrong cookie, it is still delicious. Thank you for reminding me for that. All right, what did I mess up? Reduce of empty sequence with no initial value. All right. Let's see what I'm forgetting here. Oh, forgot this one. That's the problem. Yep, more problems. Wrong type. Oh, what is the type that comes from reduce? I bet it's a list of some sort. No, reduce should be a simple thing. Let's go ahead and print OR expressions. Oh, this isn't Python 2. Get out of here with that gross stuff. Oh, it's an expression object. It gets returned back. Oh, I think I had this issue last time too when I was doing all this stuff. Oh no, I don't want these. these, the and expressions are I want the index right there. And then I'll have to do it on the other one too, I think, but that should at least get me a little closer. Yeah. There we go. We'll get some nice instructions back. Let's see what happens when we print reaching condition now. Let's not print the edges. And let's not print the or expressions. Yeah. And those are our reaching expressions as medium level IL instructions. And so we can switch to this. All right. So that gets us the reaching condition, the condition node. So then the next thing we want to do is, I think, add a sequence node underneath that. New condition node. And then we'll do a condition node dot append medium level IL AST sequence node. And then we will add BB. And then region node will append new condition node. So that should give us something. Let's see. Get rid of this. And we have our regions. Are the regions themselves ordered? I guess we can figure that out from there. We can sort those based on the keys. This should be Lyle. Should just be that, I think. Okay. So now we should be able to do a... Do you really want to play with Java though? And also, why wouldn't you want to write a decompiler? Like, I'm doing this for me. Fuck y'all. I'm learning a shit ton doing this. Let's see. So I think I want to make a let's make a string. Then we can just print it. I can figure out the rendering in the graph later. So first things first, we want the we want to output the first basic block. Let's see, do I have a block? Yeah, dot block. If il.instruction index is not equal to root.block end -1. Let's do this. All right. So we got the first block. Let's see what happens when we try that. Oops. What did I break? Sequence node has no children? Did I forget to call super? Yeah. Oops. Oh my gosh. So we got all of that. Cool. All right. Instruction shouldn't be a bull. Instruction. Did I do 0? No, I need basic blocks 0. That's my problem. Oops. And I guess actually returning string would help. I'm gonna take out that other print of the blocks. Okay. Okay, good. Where was that print? Print ordered region. Okay. Then wait, did I actually do anything with that region? Region node. Self.append region node. Maybe I should add strings to these. This is not the right thing. This is a IL instruction. This should be let's just return a list of the children for now. And then here we can do why does it always do a tab in like that? So weird. Child in self.children. Yeah, it's annoying, huh? One, two, three, four. I don't have a good way of tracking indentation here. Okay, I can't do it like this. I have to do it in the main one. That sucks. Let's print region first and see what we've got. It should just be a bunch of sequence nodes. Nope. There's no append. Was I doing it based on BB? Where am I using this? Do I do self anywhere? No. I don't think so. Nope, doesn't like the stir has its own thing. Probably takes like an iterable or something. Encoding. Yeah. All right, what was I doing then here? Nodes. Maybe I was setting them based on their BB. All right. So then regions are regions is my nodes basically. Oops. That's the only place it was. forgot to change the append. No, I don't like that. Because now regions is... Regions is a list of basic blocks, and I don't want to confuse that later. So maybe I do need nodes. Ugh. Let's fix all that. I think that's what I was going for. And then down here we do was there a children up here too? No, I don't think I had one. All right. Okay. Why did it print out block there? Where are you printing things? Oh. I should have 2 nodes there. So why is there only... Oh, because I'm only just structuring acyclic region 1. Duh. So let's change this for in a.regions. Oh, no, it's just... Yeah. There we go. And then we want to do sorted nodes. Oops. Damn it. All right. Let's see what. Actually, I can just do like a. Let's at least add. We can at least do this. Return level ILAST sequence node start equals, oh no, header equals self dot. Didn't actually save it. Let's see if that actually works. Nope. Oh, I bet it wants. There we go. So let's see. It's 12 to. So these are the nodes. So 12 to 34 is this one. Those are not sorted. And that has no children. 4 to 7 is this one, and it has no children, which is correct. And then 3 to 4 has these 3 children. That's correct. Okay, cool. So We can do this again. Let's do this. It's a little easier to read. These should be one child, I believe. All right. Okay. I don't need this A nodes anymore. Oh, that's getting me the... No wonder, that's getting me the keys. I want the items. What does F do on Pi3 strings? It takes whatever's inside them and evaluates it and outputs it into the string. So like this one here is just taking the IL expression, the instruction, and putting it in the string. So that way you don't have to do, it's just like putting .format at the end of the string, but you can do it inside the string instead. It's one of the reasons why I love Python 3. Oh God, get the fuck out of here. No. Oh. I'm so disgusted by that, I have to eat some cookie. All right. Let's see. The next thing. I need to do this differently. I need to make a region for the main block. Okay. Well, I know the reaching condition for the Yeah, so I need to make a region that is everything underneath the structure. So let's do a structure regions. And this is going to be for nodes self.node. And if the branch dependence of this equals if not, so if it's an empty list or empty dictionary or whatever, then continue. If header dependence is we'll deal with this if it's possible, because I'm thinking that it's not. I think that everything here should be dependent on one side of it or none. So then here we're gonna say new region equals node equals a medium level AST condition node and that is going to be, let me see here. No, wrong 3. Two. Looks like I can only do the one. It's a dictionary, so I'll still just do this. Okay. Oh, right, the reaching condition has just the branches. But I have here with the branch dependence, I have the index and the expression and the IL branch dependence. So branch, yeah. New region node equals and then I want dot function dx dot condition. Here we got to create one. It's just gonna be function dot do this again, and we want self dot function idx dot condition dot expression index, the index. Actually, all right, this is better. All right, and then new region node, medium level IL, condition node, self, false expression. And then else, I'm gonna raise a not implemented error. I have never seen this because there is a not branch dependent enum, but I never see it. Like they just don't add the ones that are not branch dependent. All right, and then yes. So new region node dot append, and that is going to be nodes. So now we're taking the sequence node for the tops of the regions, and if there's a header dependence on them, or if there's a branch dependence on the root node, then we turn it into a condition node and replace it. And That do self nodes header equals new region node. So in this case, we now should end up with, we have 3 regions. This region here, that is 3 blocks, children, and 1 header. Then we've got this block over here, that is its own region, and then we've got this block here that's also its own region. And so this block will be converted into a condition block with just EAX doesn't equal 1, and this one will be turned into a condition block as well with EAX equals 1, and then this one will stay a sequence block with a single block. And that way we can then order these in the correct order, which is going to be this condition block, then this condition block, and then this sequence block. So let's see what happens there. I don't know what I'm, seriously? Okay. And then, wait, let's, all right, got that one, got that one. Got that, and then let's do a dot structure regions. Didn't actually do any syntax errors or anything. Look at that. We have our 2 sequences right there. And then we've got our 2 conditions, and then we've got our sequence block. So from there, yeah, and those are in the right order. So let's see then what we can do right here. Man, why does it keep doing that? All right. I think I want a list. Yeah, which is going to be node for node in I think I want reversed. All right. All right. We're gonna do to visit. Let's see. So I don't want to pop this off until I visit all of its maybe let's see, visited equals set. And let's see. If all child in visited or child in node.children. That means I'm probably gonna have to do hash. Actually, no. I don't think I can do it like this. I need to do this. All right. So if is instance node medium level IL AST sequence node, then IL in node dot. I need to add a header property. I really should add slicing to a basic block. That'd be really nice. I need to put in a pull request for that. Let's see. So then I'm gonna do let's just do 2 for now. And then we will do, oh yeah. That is instance node medium level IL AST condition node. Then add this first. Node.children. Since it's a list. So that is how we did the structure regions. Yes. Oh, that's something I should do here. If this is not anything, then I'll need to set that up. We'll deal with that a little bit. All right. So first is going to be output plus equals all right. So I want to keep track of my indentations. So that should, for the sequence node, I don't want to increase the indentation. But then here, oops. All right, and then I want to do node.condition. Whoop. Just hit page down or something. Cool. And then this one should be node.children. Repeat indent +1. This needs to be reversed. So that they get popped off correctly. I think that might actually work. Let's see what happens. I'm sure it won't work on the first try, but we can try it. Oops, I forgot the if. Definitely some issues. It's popping the wrong thing, it looks like. Also left off the new line here. Maybe it did print it correctly. Yeah, that that looks right. So we've got the ifs in the right places. Got a bunch of stuff underneath them. Of course, it doesn't put the right things for the, we don't do symbols yet. Actually, I wonder what happens if I do. I don't think. This might not work. I might have to do a list or a generator. Whoops. Oh, right. Yeah, text token. Oh no, its name is T. Yeah, that doesn't give us the, I was hoping that would give us the symbol. If t.type doesn't equal function token type, not really. You're not gonna give me my undefined variable I. It's not gonna give me my completion, huh? All right, fine, I'll get it like this. I think I want possible address token. Actually, you know what? Let's do this first. Let's just see what everything looks like. Oh. All right, here we go. Okay, possible address token is what I want. This is gonna look messy. I'll have to clean it up. Let's just do that, just so I can see how many of them it does. Really? Ugh, I keep doing this. There we go. Really? It doesn't seem to have an issue in the Python with it. All right. Now, do you have an issue with that? Okay, you do have an issue with that. What is your issue? Oh, it's the else maybe? Yeah, that's what it is. Okay. Fine. IL tokens. Oh, now it's gonna give me the things. Token has an address, I believe. No, t.value. If self.function.view.get symbols t.value tokens plus equal so I won't have to do this when I do the flow graph part. Maybe I should just be doing the flow graph part, but it's easier to reload it this way. Wait, now let's do I'm not trying to be super efficient right now. See if that works. What am I forgetting this time? Something. Gotta make this easy. All right, what now? Wrong type. That should have worked. T.value, possible address token. T.value should be the I want to see what this outputs. Okay, why is that the wrong type? It's an integer. Unless you're showing me some white space. Yeah, it's an int. What does being get symbols in range want? Argument 3. Count? All right. Let's go look at this. Oops. What, 2686? No. $26.86. Does it convert? Start. What's it? This is frustrating. Oh, that is not used memory. That's an uninitialized data. This is the only one that we actually care about. All right, what's going on here? Okay, so it's not working at all. Get symbols takes a, according to this, whoops, not this one, takes an optional link, should only need, I bet that's it. Let's try it. Yeah, that needs to be 1. All right, that's a bug. Found a bug today. At least it doesn't crash. Just a run-of-the-mill API bug. Where was I? Symbols. All right. And you're still giving me issues. Argument 3, wrong type. Why do you work here? That's argument 5. All right, handle, start, length, wrong type. Did I forget to save or something? Oh, right. I had 2 of them. Duh. List object has no name. There we go. Yeah, that looks a little better. That's what it looks like. All right. I need to do here. Il dot instruction index equals node dot header dot end -1. And il dot operation is not medium level il operation dot mlil ret. Ret hint. Yeah, that should get us our return value. Nope. Did we lose it already? Did I cut it off on something else? It is the basic block, right? Yeah. Let's see, doesn't he? Oh. Oops. I got this backwards. De Morgan's to the rescue. All right, so I feel like that's pretty cool. Let's make the indent bigger. I want to add some line breaks. Let's do prev indent equals indent. And say if indent doesn't equal prev indent, output plus equals oh wait, let's see if indent is less than previous indent. And then we should get my kids came home surprisingly early today. Yes, I was farting all over the place. No, my kids are home and one of them decided to open the door. So I need to finish up. I did not know they were going to get home right now. So let's finish this and see if we get some nice line breaks. Yeah, that looks a little bit better. That's easier to read. Cool, and there's our return. So yeah. Yeah, seriously, stream crashers. Hey, that's some cool progress that we made today. That's exactly what the what it should look like. So next time we will do some simplification on these, and then we'll start combining if else's, and then we will. What do you mean flatten the printfs? That doesn't even make sense. What are you talking about? Anyways, after that we'll go on to the that'll happen in the flow graph. I'm not worried about it. I just wanted to do the nice symbols for the function calls, so it at least looked like pseudocode. Then once we can do the if else's, then we'll move on to switch statements, and then we'll do loops, and then we'll put it in the flow graph node and get all of our nice tokens and everything. And by then the UI plugins should be on dev, and we can actually make our medium level IL linear view that pops up automatically. So that's going to be exciting. So next episode is going to be Thursday at 3 p.m. Pacific. Hope to see you then. Thanks everybody for hanging out today, and I'll catch you next time. Have a good night.